This video is for 9.5 lesson. So we are going to be working on writing and graphing inequalities. So you might be a little hesitant with that word inequality, but we've done these before. So the inequality just means that they are not equal. So, right, you're greater than or less than sign. So we are familiar with those. It just sometimes can sound like a big word. So we're going to write, and then we're also going to graph to show all of the different solutions, because sometimes a problem can have more than one correct answer. If I just want to know, right, that X is greater than 25, and it can be anything bigger than that, right? I have an infinite number of solutions that it could be, and we're going to show and represent those. We're not going to write them all out because I would take the rest of our lives. So we're going to use a graph to show like X could be any of these things. So make sure you have a paper and a pencil, and let's jump into task 1 when you're ready. So some things we need to know before we get going is that inequality is just showing that the two relationships are not equal. So we can do that with a less than sign and a greater than sign. So we should be pretty familiar with this one and this one. That's right. The little side always points to the smaller. So if I said 4 is less than 7, or I could flip that around and say 7 is greater than 4. So you can see the big side always opens up to the bigger number. The point points to the smaller number. So some that we are maybe not as familiar with is a greater or is a less than or equal to sign. So you can see it still has the less than sign, but it also can be equal to that number. So for example, if you were going to ride on a ride at the fair and you had to be at least 40 inches, so so you have to be 40 so X has to be less than or equal to 40. Or sorry, it has to be greater than. So X would be bigger, 40 would be the smallest you could be. So you could be 40, you could be 40.1. So 40 is less than X or equal to it. So you can also flip that around. And recently, my family was at a little amusement park, and you couldn't be taller than a certain height to ride the ride because it was for little kids. And so 40 was the greatest you could be. You could be exactly 40, but if you were 40.1, that was too big. So anybody could ride the ride if they were 40 or smaller. So 40 was the greatest that they could be. So all this means is, right, it has half an equal sign, half the less than or greater than sign. And it's just saying it can be exactly that or bigger or smaller. And these are just saying it has to be bigger or it has to be smaller. It can't be exactly that height. So let's look at our problem here. So it tells us that a record-breaking low temperature of negative 23 degrees Fahrenheit was recorded in Seminole, Texas on February 8th, 1933. So negative 23 degrees. So first we just want to find and graph negative 23. So if we remember all the way back from module 1, our negatives are always to the left here and the positives are always to the right. So right, we're going negative. So here's 2, 4, we can see it's counting by 2s. So the integers on either side of negative 23 as I'm going across to the left. First, I should get to negative 22, negative 23. The next one would be negative 24. So I can see on here there is no negative 23, but it's halfway between negative 24 and negative 22. So right here would be negative 23. So in Texas, there were also temperatures of 4, negative 3, negative 14, 1, and negative 19. So let's compare where those are. So here we have positive 4, negative 3, negative 14, positive 1, and all the way down here, negative 19. So if we are comparing these numbers here, negative 23 is colder than all the rest of these. So negative 23 is less than all of these other numbers, and negative 23 is the coldest temperature out of all of those because it's farthest to the left here. So the next part, I want us to think about what are some numbers you know that are greater than negative 23. So let's put that number line back up here. So here's 0, here's negative 23. I want you to see and pause the video and write down 5 numbers that you think are greater and bigger than negative 23. So anything that is to this right direction of negative 23 is going to be greater than negative 23. 0 is greater than negative 23. I could say 1 million is greater than negative 23. 7 is greater than negative 23. Negative 5 is greater than negative 23. I could even say negative 22.99 is greater than negative 23 because it's to the right of it. So anything to the right is always going to be bigger. So now I want you to pause and see if you can write down 5 numbers that are smaller or less than negative 23. So anything to the left is going to be less than negative 23. So I could come over here and say negative 50 is less than negative 23. Negative 1,000,000 is less than negative 23. Negative 42. I could even come right here and say 23.01 is less than negative 23, right? If I owe someone $23, that's less than owing somebody $23.01. So anything to the left is smaller. Anything to the right is going to be bigger. Understanding this is going to help us make solution sets to help us with our math today. So we are going to have X represent the temperature. And so any temperature, we're not sure yet. And we want to complete an inequality. So remember, an inequality is just not equal. It's going to compare them. So not equal, so no equal sign, but it has some sort of symbol to compare their relationship. So we want to describe something greater than negative 23 degrees. So I want X to be greater than negative 23. So let's just write it out exactly as it says. X is greater than, and it doesn't say equal to, just bigger than negative 23. I just followed along with the words. X is greater than negative 23. When I read my inequality, X is greater than negative 23. I can flip that around and I can say 23 is less than X. But notice I had to flip my sign as well. When I flip the order of my expressions here, we need to flip the order or the direction of our comparing symbol. So we want to make a solution set for X. So what we're going to do is we're going to say X, and we put these little brackets to say these are just some possibilities. And I like to do a solution set of 3. You can do more, but I wouldn't just say 1, try 1, because this solution set is going to help us make sure that we graph in the right direction coming up later. So these brackets show these are just some possibilities, and this is what X can equal. So we already talked about numbers greater than 23, negative 23. I can say that 4 is greater than negative 23. I can say that 100 is greater than negative 23, right? I can even say that 22.9 is greater than 23. So anytime I plug one of these numbers in, as a solution, it should make this inequality become true. So if I put the number negative 25 in here, if I plug that in, negative 25 is greater than negative 23. That is not true. So that would not be a solution. So we want to make all of these true. So go ahead and complete task 1 with this information and come back when you're ready to do task 2.